Here is a rate problem from a previous AP test, and let's see how it works. So we got a certain work day, we got a rate of some unprocessed gravel that is arriving at the gravel plant here, and we got a function for that. Okay, T is in time, measured in hours. That's going to be important. At the beginning of the workday, we've got 500 tons. That's going to be important for an integral I'm sure we'll use here in a second. And we know that it can process 100 tons per hour, all right? So that's going to be a linear function there, 100t, all right? So that's how much can be processed. So all right, let's start with G prime of 5. So G prime of 5, well, first we've got a G prime of t. And sometimes on these calculator required problems, it's not worth the time to go write down the derivative. So right now, this is not a hard derivative to find, so let's go ahead and find that. The 90 goes away, of course, and we got derivative of the inside times the derivative of the outside, so a little chain rule. And so we have derivative of the inside, this is like 1/18 t squared, which would be 2/18 t, or 1/9 t, all right, times the derivative of the outside, derivative of 45 cosine would be 45 sine. Negative, actually. Derivative of cosine is negative sine. All right. And that's going to be t squared over 18 inside. So G prime of 3 is, wait a minute, we don't want G of 3, we want G of 5. Got to read the problem carefully. So we get negative 24.588. 24.588. And that is negative, which is the most important thing. Now, let me show you maybe a little quicker way to do this. You don't have to show all this to the AP people, especially if it's, calculator required. So we have this function. I'm going to go ahead and enter this function. You can do this into your TI Inspire calculator or whatever CAS calculator you're using. So we have 90 plus 45 cosine t squared over 18. Now you have to enter this as G of t. Capitalizes. So you can do G of x. That doesn't matter. So if you're graphing it, then it's going to want an x. Will work nicely in many cases, but I'll just make it the same as it is. And you can see the graph there, kind of interesting graph. We're talking from 0 to 8, so right in this range right here. So it looks like it's pretty much a decreasing function, which is what we know because the derivative is negative 24. So, but again, this is, we don't want to go take time to find the derivative by hand, and that's not required of us. So what we can do is we can ask Desmos to find G, and it understands prime. I think I need a shift. Prime of 5. And there you go. So Desmos or TI Inspire or Wolfram Alpha will also as well. But your CAS calculator will find this. All right. So you can actually get on your TI-84 and other calculators as well. There's a derivative function there. All right. So we have negative 24.588 as we already said. All right. Great. So, and we need some units on this. So this is negative 24.588, and this is tons per hour. Remember that a derivative is a rate, like feet per second, or in this case, tons per hour. And so what we know is that the rate is decreasing. The rate that the gravel is arriving is decreasing. And that's an important term, decreasing there by 24.588 tons per hour. And that's just at t equals 5. Okay, so remember that at this time, t equals 5. Okay, so that's the key there. All right, so we know that it's decreasing. Now we're going to peek, by the way, here. Over here I have the scoring guidelines. Notice that we're going to get 1 point. This is the scoring guidelines for this problem from the AP board. So 1 point for finding G prime of 5. 1 point for interpreting it with units. So not just an interpretation, but make sure you have the correct units there. All right. B, let's move on to B here. Find the total of unprocessed gravel that arrives at the plant during the operation during the workday. Now, a total is an accumulation. We need to add these all up. This is a sum. It's an infinite sum because gravel just continues to arrive. And so infinite sums are integrals. So we're going to integrate this from 0 to 8 of G of t. You don't even necessarily need to write it out. It's not a complex function, so you're welcome to go ahead and write that out. Doesn't hurt in this case, but really they're not looking for that. All they're looking for is this. And then, all right, now we can go ahead and compute this. Again, this is a calculator problem, so we just need the integral from 0 to 8 of G of t. Normally on these problems, they kind of work their way up. So the first ones are a bit of a direct computation, and then it gets a little more theoretical. So we can see that the integral from 0 to 8 of G of t, again, don't need to type because we have the function there, is 825.551, all right? So 825.551 is what we get. So this is 825.551, and that's tons. And then we need to write that in the context of the problem. And so we end up with 825.551 tons coming per day. So 825.551 tons of gravel arrives during the hours of operation. All right. So moving on to the next question here. The question is the amount of gravel increasing or decreasing at time t equals 5? Okay, so we got to look at the rates here. So increasing or decreasing is the rate of change. And we know that the rate that it is coming in, so the rate here we said is G of t, of course, and then the rate that is being processed is 100. So the process rate is 100. Okay, so let's call that process is 100. So then this is tons per hour. Okay, so they're filtering or whatever they're doing here. So then we know that P of 5 is going to be 100 because that's constant, all right? And we know G of 5, we can go figure that out, is, let's go figure that out on our calculator here. There it is, 98.141, 98.141. So the G of 5 comes from the formula, of course, and the P of 5 is constant. So since P of 5 is greater than G of 5, since 100 is greater than 98.141, which is G of 5, That means they're processing more than is coming in. So it's decreasing. So the amount of gravel is decreasing. So it's the amount of unprocessed gravel is decreasing at t equals 5. Do remember to be specific about the time. So it's just at this time, understanding that it's time specific. All right. So that's the idea there. Now the next one here is kind of a challenging one here. We've got to keep things straight here because G of t is the rate and P of t is the rate. Okay, so we want the maximum amount of unprocessed. So we're talking the amount of unprocessed gravel, okay, at some time during the hour of operations during the workday. Okay, now we know that at the beginning of the day, let's look at the question again. It starts with 500 tons, so there's already some gravel sitting and waiting. Okay, so if we want to figure out at any time, we want to find out how much gravel is in or the unprocessed gravel. So let's maybe call that U. I'll call it U for unprocessed gravel. So the unprocessed gravel is going to be 500 plus, now we have the integral of the rate. So we're going to add the rate, okay? So then the rate is 100 is what's coming in. Actually, let me back up. We're talking unprocessed, not processed. So the unprocessed gravel, so we have G of t is what's coming in. And we've got 100 is the rate at which we're processing it. Okay. Now, we need some. We're going to actually write this as a dummy variable here. So G of s, and this is going to go from 0 to time t. All right, so we've got to accumulate. So an integral is an accumulation function. All right, so we're going to accumulate or total up all of the rates. And we've got to connect these rates because we have, they're acting, this is decreasing the amount of unprocessed gravel. This is increasing the amount of unprocessed gravel. And we started with some unprocessed gravel. All right, and so the question is this. The question is, when will we have a maximum or minimum? Just maximum. We don't care about minimum. So maximums happen when the derivative is 0. So U of t will be a maximum when the derivative is 0. Well, let's find the derivative of this. We don't care about the 500. The derivative of this, well, the derivative of an integral is the second fundamental theorem of calculus says that cancels out. And so actually it'll be G of t minus 100. All right. And we want to set that equal to 0. All right. So we need to check, and we have some endpoints as well. So when is G of t equal to 0? G of t equal to 0. I'm sorry, equal to 100. Add 100 to both sides there. Okay, so we need to find that out here. Let's go find this. Okay, so we want G of t equal to 100. Now, if you have a TI-89 or a TI-Inspire, you just solve that equation. We're just going to set G of t, 90 plus 45 cosine t squared over 18, set that equal to 100 and solve it. All right. Well, for this, oh, I just lost it. All right, I've typed it back in there. Now we need to set that equal to 0 or 100. So we want to know where that equals 100, and so we're going to say G equals 100. Let's see. I wonder if it'll. And really, we just want y equals 2. So let's go y equals 100. There it is. All right, so we want to know where this crosses, okay? And so we need to know, let me zoom in here, that might help. So we should have a point here, right there, at 4.923, t equals, or the g of 4.923 is 100. All right, and that solves our equation. So t is 4.923. Now we've got to check. We're looking for a maximum and minimum on an interval, and so we need to do a table of values. We got some times, and we got some u of t's. Okay. Now we know at time 0 we have 500, and we're going to need to compute this 500 plus the integral there. Compute that for 4.923. So we have 500 plus, go find my calculator here. So we've got our integral, 500 plus the integral from 0 to 4.923 of g of, we can use s or t as long as you do the same in your variable of integration. So minus 100 so we're going to compute that, and Desmos, so your TI-83 or that would do it, or your TI Inspire will do that. So 635.376, 635. And then last thing we need is at 8 seconds what's left. So let's just go change this to 8 seconds. Let's get rid of this 4.923. At 8 seconds we have 525.55. 525.551. All right. 0.551. Okay, so that's our unprocessed gravel. So we do have a maximum at 4.923 hours. So at 4.923 hours, there will be a maximum of 635.376 tons of unprocessed gravel. All right, that's what we have. All right. So a little challenging there, because the key here to connect is that these are rates. The 100 and the g of t are rates. To find the maximum amount, or to find a total amount over time, we need to integrate a rate to find a sum or a total. Integration is a sum. Integration adds up all of the individual infinitesimally small amounts that are constantly changing. That's the power of calculus. All right, so when you're looking at rates, looking for those things there. The rate is the derivative. All right, so, well, I don't know what happened there. Hopefully that helps with rate problems and seeing some general patterns there. And keep working hard. You're going to do great on that AP test. Keep it up.